Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking at Geometry Part A. This is Lesson 3. In this lesson, we're going to talk about perpendicular lines. In this recording, we're going to define what a perpendicular line is. We're going to take a look at perpendicular lines in the coordinate plane. We'll determine if two lines are perpendicular. Then we're going to write the equation for a line perpendicular to another line through a given point. So what are perpendicular lines? Perpendicular lines are a pair of lines that intersect to form a right angle. So if we take a look on the left, you see we've got a set of lines that intersect. You see we've got the right angle symbol right there. That means those are perpendicular. We look at the ones on the right. See, these are intersecting lines, but there's no right angle symbol, and you can kind of obviously tell that that's not a right angle. So those are intersecting, but not perpendicular. So here are a couple of examples of perpendicular lines in the real world. If you've ever been to a house and had a set of French doors, you notice the French doors, they always turn out to have those nice lines across. Those are right angles, those are perpendicular lines. And if you take a look at certain floors and floor designs, a lot of the times they do have those perpendicular lines. The lines crossing each other at right angles. So if we want to identify perpendicular lines using notation, for example, if line M is perpendicular to line M, we would just state, using this perpendicular angle symbol, which looks like an upside down T, that M is perpendicular to N. So in the coordinate plane, the X and Y axis form a pair of perpendicular lines. So that means that any pair of one vertical line and one horizontal line will form a set of perpendicular lines. Now, those are not the only scenarios, so we're going to talk about some of the other scenarios now. So now that we're in the coordinate plane, when we look at lines that are perpendicular, we have to focus on their slopes. So lines are perpendicular when they have slopes that are opposite reciprocals. So if we take a look at this example right here, we've got two lines. We've got that light blue line, it has a slope of 1/2, and then we have this kind of orangish line, it has a slope of -2. Opposite reciprocals. Number one reciprocal, the reciprocal of 1/2 is 2/1. So that's the reciprocal part. And then the opposites means one would be positive and one would be negative. Now, another way that we can look at this and describe this is by focusing on the product of slopes. If the lines have slopes that have a product of -1, so in other words, we multiply the slope from the first line and the slope from the second line and we get -1, then we know that the lines are perpendicular. Now, if we take a look at our example again, the kind of bluish line has a slope of 1/2. The orangish line has a slope of -2. So if we multiply those, we get -2/2, which when we reduce becomes -1. And that's the best way to determine if lines are perpendicular. So let's take a look at some of the problem solving skills we have to do in this lesson. So we're going to look at this following example here. It says, would the following be perpendicular? So I've got a graph with a line and I've got an equation. Well, I know that the equation, let's start with that because it's the easiest one to kind of work with. It's in slope-intercept form, y equals mx plus b. So I know that the slope of that line is -3/2, because that's the m right there. So in order for the line to be perpendicular to this blue line that we're given right here, in order for it to be perpendicular, it would have to be an opposite reciprocal slope. So the perpendicular slope would have to be 2/3. Remember, we find the reciprocal and then change the sign. And remember, you can also look at the product. So are the products equal to -1? So let's take a look at this line and let's see if we can find some points that we can use to help us find the slope. So here is one point right here, 0, -3 right here. So we're going to look at that point, and then we're going to look at this point right here. We'll look at this point. So let's take a look and see if the slope of this line is 2/3. So if we draw our right triangle to help us find the slope, the rise is 2 and the run is 3. So the slope of this line is 2/3. Since 2/3 times -3/2 equals -6/6. Yes, these are perpendicular. So here's another situation. Are these perpendicular? Well, this is two lines. So in order to figure out if the two lines are perpendicular, we're going to have to find the slope of each line. So let's take a look at the blue line first. So let's see if we can find a couple of good points on that blue line. So here is a good point right here, 0, -4, that's the y-intercept. And then let's see if we follow that line. Unless you're absolutely sure you don't pick that point. So that looks like a good point right there. So I'm going to find the slope by drawing my right triangle to connect those two. So here's my right triangle. And this has a rise of 1, 2, 3, 4, 5. And a run of 1, 2, 3, 4, 5, 6, 7, 8. So that means the slope of the blue line, I'll put blue there, is 5/8. So in order for these two to be perpendicular, that means the slope of the red line would have to be -8/5. If it's not -8/5, then we know these are not perpendicular. So let's see if we can find two good points on the red line. So on the red line, looks like 2, 0 is a good point right there. So we're going to mark that point. And then let's see if we follow that line. I'm looking for a point that's a crosshair point, I like to call it. Goes right through the intersection, like this one right here looks like it does. I'm going to pick those 2 points. I'm going to draw my right triangle. And then I'm going to count the rise and the run. The rise has to be 8. We know it's a negative line, so we know it's going to be a negative line. So this rise has to be 8 and the run has to be 5 in order for these to be perpendicular. So let's count. That's 1, 2, 3, 4, 5, 6, 7. Well, the rise is 7. And the run is 1, 2, 3, 4, 5. So the slope of the blue line is -7/5, not 8/5. So since 5/8 times -7/5 does not equal -1, these are not perpendicular. Let's take a look at our next skill we have to do here. Now, this is the big skill here. This is something you could have done in Algebra 1. So maybe you saw it in Algebra 1. It says write the slope-intercept form equation for the line perpendicular to the following that passes through 6, 5. So we got to find the slope of this blue line. That's really all we need to know. So just like on the last ones, I'm going to find 2 good points, and then I'm going to use those points to find my slope. So it looks like 0, -1 is a good point. If I follow that line, nothing really, that one's close, but you can see it's right under that crosshair like I like. So it looks like the next good point might be right here at this little intersection right here. So drawing my right triangle there, I have a slope of 1, 2, 3. So a rise of 3 and a run of 1, 2, 3, 4, 5. So that means the slope of the line is 3/5. Now remember, we want to write the perpendicular line. So I can't use 3/5. I have to use its perpendicular slope. Remember, it's an opposite reciprocal. So we're going to find the reciprocal. We're going to change the sign. So my reciprocal will be -5/3. So now I'm going to use point slope form. So y minus y1 equals m times x minus x1. We use this point and this slope. So I got y minus 5 equals m, which is -5/3, times x minus 6. That says we want the slope-intercept form. Well, that's point slope form that we have, so we've got to translate it to slope-intercept form. So we're going to distribute. We got -5/3 x. And then we'll do a little work right up here at the top of -5/3 times -6. And so that's going to give me 30/3, which equals 10. So that'll be plus 10. And so now to get it in slope-intercept form, just going to add 5 to each side. I got y equals -5/3 x plus 15. I forgot my x. There it is. So for these problems, you got to have the slope. Once you have the slope, take the point that you're asked about, go to point slope form, substitute, and then solve for slope-intercept form. And then our final example here, it says find the slope-intercept form equation again for the line perpendicular to y equals -x plus 5 that passes through the point 8, -8. Well, what's the slope of this line? Well, there's no number there, but we can assume that there's a 1 there. So that means my slope is -1. Well, what's the reciprocal of -1? Well, the reciprocal slope of -1 is +1. Because if you multiply those two together, you get -1. So my slope for my perpendicular line would be 1. I'm going to use my point, 8, -8. Go to point slope form. Substitute what I know. So I know y minus -8. Make sure you take care of the signs here. The slope for our perpendicular line is 1. And then we have x minus 8. And again, get it in slope-intercept form. 1 times x is 1x, or just x. 1 times -8 is -8. We're going to subtract 8 from each side. And so our perpendicular line will be y equals x minus 16. So I hope this helps you with the lesson for finding perpendicular lines and knowing what perpendicular lines are, how to determine if two lines are perpendicular, and how to find the equation for a line perpendicular to another line through a given point. So if you're struggling with this content, please let me know in a teacher message or make an appointment for a help session.